So the topic of this section is what's called a for loop. And this is going to be a big increase in what we can do with the code. So if you look at the original flowers image here, it's 457 pixels wide by 360 pixels high. So if you multiply just to get the total number of pixels, that's 164,000 and a few odd pixels. And this is a pretty small image, so that's a lot of pixels. So the way we were writing code before, where you would have a line like pixel.setRed 255 to change one pixel to be red, that's not a practical way to do an operation on a whole image. I mean, this is a small image and it has over 100,000 pixels. So what we want is a construct where we can write a few lines of code that capture some change we want to make, and then let the computer take care of the bookkeeping of running those lines of code again and again, once for each pixel in the image. So the for loop, the topic of this section, is going to do exactly this. And this is going to be a big increase in what we can do with the code. So let me talk about the structure of this thing. I'm just going to identify the parts, and then I'll do an example. So here in the blue box here, I have a picture of a for loop, and I'll just talk about what the parts are. So it starts off, I'll use my pen, with this begins the for loop, so it has the word for, and then in parentheses it says pixel::image, and then there's a left curly brace to set off the next line. And so what this means is, and all of this syntax is required, the parentheses and the curly brace and everything. Usually in my examples or in the exercises, it's the same every time. So usually we'll provide it and then just ask you to write the code on the following lines. So what this means is, for every pixel in this image, please do the following. And then the following is defined as whatever is within the curly braces here. So these lines inside of the thing, that's called the body of the for loop. And this is just a few lines of code that can do whatever we want. So the way the for loop works is, and let's say we're working on the flowers image here, here we have 3 lines. So it's going to take, let's say, pixel number 1 of the whole image, the upper left pixel. And so it isolates pixel number 1, and then the for loop runs these first 3 lines. So it says pixel.setRed 0, pixel.setGreen 0, pixel.setBlue 0. So those are all happening to pixel number 1, and then really what that does is it changes it to black, right? It sets red, green, and blue all to 0. So when the for loop gets to the bottom, funny thing happens. I sort of have this black arrow. It loops back up to the top of the 3 lines. And now it's going to isolate pixel number 2, so the second pixel, and then it runs these 3 lines again. So it does them to pixel 2, and then it loops back to the top, and it runs the 3 lines again for pixel number 3, and so on. It just runs the lines again and again and again, once for each pixel in the image. The other thing I should point out here is you'll notice that the 3 lines in the body are indented, and that's not required, but it's a common convention to show that the lines in the body are kind of different from the other lines of code, where this image equals new simple image. Well, that just happens once, and the print image, that just happens once. But the lines inside the loop are sort of special in that they have this quality that they're going to be run again and again. So let's try. We can just run that exact example. So here I have it in runnable code. So this loads the image. Then I've got the for loop setting off the body. Here's the 3 lines of the body, and then it's kind of small here, but then there's a right curly brace sort of balancing the left curly brace up here that closes off the body. So let's just run it and see what we get. So you can see what we get is just this pure black rectangle. It's not very useful, but it does show what the for loop does. So what's happened is we had this original flowers image with all sorts of red and green and yellow and whatever in it. And what this code has done is it has visited every pixel in that image and done these 3 lines. And what these do is they set the red, green, and blue all to 0. So in effect, it just changes the pixel to be a pure black pixel. And so then if you imagine that just happening over the entire flowers image, obliterating all the data, this is what we're left with, just this pure black rectangle. All right, so let me try a more interesting example. So here, I'm going to say for each pixel, set red and green to 255 and blue to 0. So I want to think about, well, what's the code to do that? Very often for these problems, we'll have the pattern that in English, I'll say, well, have, do this effect, set red to 255 or whatever, and then ultimately on the exercise, it'll be your job to sort of translate that into code. So this is an example of that pattern. So the code to put in the body to change red and green to 255 and blue to 0 is just to say, the first two lines say pixel.setRed 255 and pixel.setGreen 255. And then the third line is pixel.setBlue 0. So if I run that, what we see is just this bright yellow rectangle. So this is kind of similar to the previous example. We've just gone through and changed red, green, and blue for every pixel on this thing, in this case to sort of this vivid yellow color. So so those two examples are a little unrealistic, right? We just obliterated all the data and just made this colored rectangle. So now I'd like to try one that's a little more realistic, where we, instead of obliterating all the data in the flowers image, we work with it. So here's the original flowers image. And as we know, yellow equals red plus green. So we would expect that here, where I've got the yellow flowers, that the red and green are high there. So what I'd like to do for this example is set the red to 0 for the whole image. Think about what that's going to do. So the first question is, all right, well, what's the code to do that? And in this case, what you see is I just have the line pixel.setRed 0 as the body. Now, in my previous examples, the body was like 3 lines of code. It can be anything, so it could be 3 lines or 6 lines. In this case, it's just going to be 1 line. And what this said, the sort of English translation of this for loop is, for each pixel in the image, set the red to 0. So let's see what that looks like. So if I run that, what you see is there's sort of the flowers have changed to look like these kind of weird radioactive green flowers. And that makes sense if you sort of unpack, like, well, what made the flowers yellow before? Well, they were yellow because there was a combination of red and green light. What this code does is it just zeroes out all the red light. It's like we just turn that lamp down to 0 everywhere. And so what we're left with is just the green light that was making the images. The other thing to notice is, look over here, the green leaves kind of on the lower right. They don't look much different at all. So probably this was mostly green light to start with. The red light was maybe valued like 8 or 20 or something. And so when we change that to 0, it doesn't really make much visible difference. All right, so let me try one more example here. So for this one, I'm going to start with the flowers image, and I'm going to say set green and blue to 0 and leave red unchanged. So what is the code for that? Well, I'm going to have a 2-line body here. I'm just going to say pixel.setGreen 0 and pixel.setBlue 0. And I just don't change the red, so it'll be left at whatever it is. So we can run that. And what you see is now we get these red flowers. And what's happened here is this is actually called the red channel of the image. And what's happened is normally the image is this combination of red, green, and blue light. What we've done is we've changed both the green and the blue to 0. So we've turned those down to just be nothing. And what we're left with is sort of a map of where was the red light in this image. Where was red bright and where was red dark? And what we see is, well, over here on the left where it was dark, there was not a lot of red light. And also here, the green leaves, not much red there. And so really it's just the yellow flowers was this prominent area of red light. So that's just a way of looking at the image. There's actually an analogous blue channel and green channel we could make to sort of look at where those lights are alternately. All right. So the for loop, as I said, it turns out this is a very powerful feature that allows us to write a few lines of code and let the computer run them over just some sort of big data set. In this case, we're doing images. I should mention for completeness, JavaScript, language you're using, actually doesn't have a for loop that's as compact as this. It's just an omission in the language. So I added it just for this class to make it work here. So if you're doing some other JavaScript problem, I'm afraid you won't have this. But many languages do have a for loop that looks just like this. It's just sort of a weird omission from JavaScript. So the pattern here is that we get to write code, just in a sense, a short bit of code capturing what we want. And I would say that this reflects the theme of the idea that computers are powerful yet kind of stupid. So you write the code that's kind of interesting, like, well, I want to change the green in this way or that way or whatever. And then by putting it in the for loop, we have this partnership with the computer where the computer will take care of the powerful thing of like, well, running that, hundreds of thousands or even millions of times, the computer handles that end, but it is also, the computer is really just doing something very mechanical there. And so I think that does show the general theme of how computers are, that there's sort of, the computer handles the mechanical part very quickly, but the person has to add the creativity to like control what's actually going to happen. So in the next section, there's some exercises looking kind of like this, and then in the next section I need to add just one more feature that'll allow us to start doing image processing examples like this that are a lot more interesting.